Hey everyone, welcome back to my channel. Today we're going to be solving a LeetCode problem called Destroying Asteroids. It's a medium-level problem and it's a lot of fun. So let's get started. The problem states that we have a planet with a certain mass and a list of asteroids with different masses. And we need to determine if the planet can destroy all the asteroids. The planet can destroy an asteroid if its mass is greater than or equal to the mass of the asteroid. And after destroying an asteroid, the planet's mass increases by the mass of the asteroid. So, the key insight here is to recognize that we need to destroy the smallest asteroids first to maximize our chances of destroying all asteroids. This is because the planet's mass increases after each successful collision, allowing it to take on larger asteroids. Think of it like a snowball effect, where the planet's mass grows as it destroys smaller asteroids, making it more likely to destroy the larger ones. By sorting the asteroids in ascending order, we ensure that we're always attempting to destroy the smallest asteroid that we can currently handle. It's like eating a meal. You want to start with the smallest bites first and work your way up to the bigger ones. Now, let's walk through the approach. We start by sorting the asteroids array in ascending order. Then, we initialize a mass variable to the initial mass of the planet. Next, we iterate over the sorted asteroids array. And for each asteroid, we check if the current mass of the planet is greater than or equal to the mass of the asteroid. If the planet's mass is sufficient, we add the asteroid's mass to the planet's mass and continue to the next asteroid. If the planet's mass is insufficient, we immediately return false, indicating that not all asteroids can be destroyed. If the loop completes without returning false, we return true, indicating that all asteroids can be destroyed. Now, let's take a look at the code. We have a class called solution with a method called asteroids destroyed that takes two parameters: the mass of the planet and a vector of asteroids. First, we sort the asteroids array in ascending order using the sort function. Then, we iterate over the sorted asteroids array using a for loop. For each asteroid, we check if the mass of the planet is less than the mass of the asteroid. And if so, we return false. If not, we add the mass of the asteroid to the mass of the planet and continue to the next asteroid. If the loop completes without returning false, we return true. Now, let's talk about the time and space complexity of this solution. The time complexity is O(n log n), due to the sorting operation, where n is the number of asteroids. The subsequent for loop runs in O(n) time, but it is dominated by the sorting operation. The space complexity is O(1). If we ignore the space required for the input asteroids array, the sorting operation can be performed in place, and we only use a constant amount of additional space to store the mass variable. However, if we consider the space required for the input array, the space complexity would be O(n), where n is the number of asteroids. So, that's it for today's problem. I hope you guys enjoyed it and learned something new. If you did, be sure to like the video, subscribe, and comment your approach below.